Okay, so now let's do this question. Okay, so this question contains two dependent current sources. Okay, so that's the uniqueness of this problem. Okay, so here the question is, find the network shown in figure, find the value of the dependent current source Ix, which means you need to find the value of Ix. That is the question. Okay, and using node analysis, right? And this question, like I said, since there is a dependent current source, all you need to do, the only difference is that just simply write the equation of the dependent current source. That's all. Simply write the equation of the dependent current source and then treat that as a normal current source or voltage source or whatever. Okay, so when a dependent source comes, the only difference is that you just need to write the equation of that particular dependent source. So here you can say there's two dependent sources. One is Ix and the other one is V2. So which V2 you don't have to write the equation because V2 is equal to V2 itself. So you don't have to write the equation of this. But we don't know what is Ix. See, because we have only a V1 and V2. So what is Ix? Ix is the current across the 0.5 ohm resistor, right? It is the current that is flowing from V1 to V2 across the 0.5 ohm resistor. So which means the equation of Ix is equal to Ohm's law, right? Ohm's law is V by R, voltage across the resistor divided by resistor. And what is the voltage across? So what's Ix? Ix is the current across the 0.5 ohm resistor, right? So the resistance is 0.5 ohm. And what is the voltage across this resistor? It's flowing from V1 to V2, which means V1 is considered as the higher potential and V2 is considered as the lower potential. Therefore, Ix is equal to V1 minus V2 by 0.5. This is the equation of Ix. So which means now wherever you see Ix in the equation below, wherever you see the value Ix, just replace that Ix with this equation. Okay. So now let's write the equation of node V1 and node V2. So first I'll write equation for node V1. Equation for node V1. So let's see. So if you look at V1 over here, V1 has how many branches? This is node V1 and V1 has how many branches, right? 1, 2, 3, 4, 5. There are 5 branches, which means this equation will be having 5 terms, right? So what is the equation of the first term? You see, the first term, in this first branch, there's nothing but only a current source. And the name of that current source is 3V2. Right? So 3V2 is the name of that current source, right? So is it plus 3V2 or minus 3V2? It is minus 3V2. Why it is minus 3V2? Because this current is flowing in the opposite direction of the current that you assume. You see, because whichever node you are selecting, that node you are assuming that all the currents from that node are outgoing currents. Because outgoing currents can be considered as positive. This 3V2 current source is incoming current. It is incoming. It's not outgoing. It is incoming, which means it's going in the opposite direction. See, this is the direction that you have assumed, and this is the direction it is going, which means it is opposing this current, which means it is minus 3V2. That is the name of the current through this branch. Okay. And what is the name of this current through this branch? Here in this branch you can see there is an 1 ampere current, right? There's a 1 ampere current and that is also incoming. Yes, that is also incoming, or it is going the opposite of the direction you have assumed, which means this is also minus. So it is minus 1. Okay. Now what is the name of the current through this branch? You see the name of the current through this branch. Here the voltage is V1. Here the voltage is 0. So the voltage across this resistor is V1, right? Or V1 minus 0 or V1. And the resistor is 1 ohm, which means the current through this branch is V1 minus 0 by 1. V1 minus 0 by 1. Okay, that is the name of this current. V1 by 1 is the current through this branch. Now what is the current through this branch? The current through this branch, it is flowing from a higher potential to a lower potential, right? And 0.5 ohm, which means the current through this branch is V1 minus V2 by 0.5. Okay. And what is the current through this branch? Here there is already a current source, right? There's already a current source called 3 ampere, which means the current through this source is 3 ampere and it is outgoing current. Just like your assumed current, this current is outgoing, which means it is plus 3 amperes. It is plus 3. No, you write 3, plus 3. See, it is plus 3. Okay, that's all. So let me see. 1 2 3 4 5. 1 2 3 4 5. This is the equation. Okay, so now I'm going to express this whole thing in terms of V1 and V2. Okay, so which means first I'll write in terms of V1. So in terms of V1 is over here and over here, which means V1 into 1 plus 1 by 0.5. This is the value of V1. Okay, now what about V2? V2, if you look at V2 are all negative terms, right? Negative V2s. Alright, it's okay. Maybe I'll write, okay, I'll write V minus V2. It's okay. Minus V2. So this will become 3 here plus 1.5, right? 3 plus 1.5. 1 by 1.5, sorry. 3 plus 1 by 0.5. Okay. So this is the equation, right? There's no other V2, right? Over here and over here, right? Minus and minus. So it's minus, okay? So this is correct. So that's it, right? That's all. So this is equal to, now what about the source? You have here as minus 1, so it will become plus 1, and you have over here plus 3, so it becomes minus 3. So minus 3 plus 1 is minus 2 there. So this is the equation. Let me simplify it. What is 1 plus 0.5 inverse? 1 plus 0.5 inverse is nothing but 3. So this is 3V1, or I'm going to write as V1 into 3 for my own convenience. Okay, minus, and what about this? This is 3 plus 0.5 inverse. 3 plus 0.5 inverse, and you have 5. So this is V2 into 5 is equal to minus 2 there. This is the equation for node V1. Okay, this is the first equation. Now let's see the value of the second equation. The second equation for node V2. For node V2, let's see. So this is node V2. So I'm going to assume that in this junction, all the currents are assumed to be outgoing, which means the current through this branch is this one, the current through this branch is this one, the current through this branch is, here the two branches, so this one and this one, and the current through this branch is this one. Okay, so now I'm going to express the equation of 1, 2, 3, 4 and 5 currents, right? So equation for node V1, first I'll assume this current. Okay, so what is the current through this branch? It is flowing from V2 to V1, which means V2 is considered as the higher potential and V1 is considered the lower potential, and in between there is a 0.5 ohm resistor, which means the current through this branch flowing from right to left is V2 minus V1 by 0.5. That is the current through this branch. Now what is the current through this branch? Here the voltage is V2, here the voltage is 0, so the voltage across this 0.25 ohm is V2, right? V2 minus 0 is the voltage across this 0.25 ohm, which means the current through this branch is V2 minus 0 by 0.25 ohm, or V2 by 0.25. V2 by 0.25. Okay, that is the current through this branch. Now what is the current through this branch? You see the current here, you are assuming that the current is outgoing, but in this branch there is already a current called as 2 ampere, and it is incoming current, right? It is incoming, which means it is going in the opposite direction, so it is minus 2. Okay, and what about the current? That is the current of this branch. And what about the current through this branch? What about the current through this branch? Here there is, in this branch there is a current source, and the name of the current source is 2ix, which means, and this is going the same direction, right? Same direction, which this current is also outgoing. So 2i, so it will be plus 2ix. Okay, plus 2ix. That's it, right? Is there any other current I have forgotten? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, this current also, right? What about this current? This is going in the, this is outgoing, but this in this branch, this 3 ampere current is incoming. It is incoming current. So which means it is opposite direction. So it is minus 3. Minus 3. Okay. See. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are 5 terms. This is equal to 0. This is Kirchhoff's current law, right? So here you can see, like I said before, if you see any dependent source, then replace that with this equation. That's all. That's all you need to do. So here the value of Ix is over here, which means this is nothing but V2 minus V1 by 0.5 plus V2 by 0.25, and here minus 2 and minus, I can combine these two, right? So if I combine these two, it will become minus 5 and minus 5, okay, plus 2 into, what is the equation for Ix? This is the equation for Ix, V1 minus V2 by 0.5 is equal to 0. Okay, so now what I can do is, maybe I can combine these two terms, right? I can combine these two terms. So if I combine these two terms, what will happen? This 2 will get cancelled, right? So you will have nothing but V1 minus V2 by 0.5. All this will get cancelled, right? So V1 minus V2 by 0.25 plus V2 by 0.25, that's it, right, is equal to 5. Let me check. Yeah, that's it. Okay, so you'll get this one. So now I'm going to express this. Now I'm going to express this in terms of V1 and V2 only. So which means this will become V1 into 1 by 0.5, okay, plus V2 into, and what about this? This is plus V2 into 1 by 0.25, 1 by 0.25, and this is minus 1 by 0.5 is equal to 5. Okay, what is 1 by 0.25 is 2, right? So it is V1 into 2 plus V2 into, what is 1 by 0.25? 1 by 0.25 is 4, right? And 1 by 0.5 is 2. So 4 minus, this is basically 4 minus 2. 4 minus 2 is 2. So it is, this is also 2 is equal to 5. So 2V1 plus 2V2 is equal to 5. That's the equation. Okay, right. Then it's okay, right? So now all you need to do, so your job is to find Ix. So to find Ix, you need to find V1 and you need to find V2, which means you need to find the value of V1 and V2, right? Okay, and what is the equation? That is 3V1 minus 5V2. Let me write that over here. We don't have to apply matrix equation for this, right? This is only 2 equations are there. So you can solve in the normal manner. Is equal to minus 2. The other equation is 2V1 plus 2V2 is equal to 5. Okay, so what should I do? How would I solve this? You can solve any way you want. Okay, any way you want. What I'm going to do is, I will first multiply this equation into 2 and I will multiply this equation into 3, so I can cancel these to each other. So in that case, this will become 6V1 minus 10V2 is equal to minus 4, and the other equation will be 6V1, and this will become 6 plus 6V2 plus 6V2 is equal to 15. Then what I will do, I will subtract these two. So this plus will become minus, this plus will become minus, and this plus will become minus. So these two will get cancelled. So you will get minus 16V2 is equal to, this is minus 19. Or in other words, V2 is equal to 19 by 16 volt, which is equal to 19 by 16 is how much? 19 divided by 16 is equal to 1.188 volt. This is the equation for V2. Now what is the equation for V1? V1 is equal to, so if you found V2, now you can find V1, right? You can use any one of these equations. I'll use this equation. So V1 is nothing but 5 minus 2V2 by 2, right? 5 minus 2V2 by 2, which means it is 5 minus 2 into 1.188 by 2, which is equal to, let me see, 5 minus, let me write that, 5 minus 2 into 1.188 divided by 2, and you will get the equation as 1.312. Therefore V1 is equal to 1.312 volt. So which means the equation for Ix Ix is equal to V1 minus V2 by 0.5, which is nothing but, what is V1? 1.312 minus 1.188 divided by 0.5, which means, let me see, 1.312 minus 1.188 divided by 0.5 divided by 0.5 divided by 0.5, and you will get the answer as 0.248. So this is nothing but 0.248 amperes. That is the value of Ix. The value of Ix is equal to 0.248 amperes or 0.25 amperes. Okay, this is the equation.